So that is amplifier. So if the electrical signal from transistor is small, it cannot be visualized or processed. Hence, it is amplified using amplifiers. So ADC, the electrical signal from transducer is an analog signal which a microprocessor cannot process. Hence, an analog to digital converter is used. So DAC, the signal from microprocessor will be digital signal, which is going to control the analog elements like heater, cooler, etc. So for that, the device signal from the microprocessor has to be converted to analog to DAC. Okay, in 8085 we don't have input output ports, so we adding the 8255 peripheral interface. Already we discussed in the last class, that is 8255 is a port generating programmable peripheral interface. Yeah, got it. Yes. So that is 8255 is a programmable peripheral interface. It is having the some input output ports, port A, port B, and port C. Here we are using the 8255 for generating the ports instead of 8085. Okay, this is the interface between the ADC and DAC with the microprocessor conditions. Okay, so here we are using port A for data communication. Port C is for the control signal operations. So this is a process of flow chart, that is initialize the 8255 port as an input port, port C upper as an input port, and port lower as an output port. Okay, that means we are initialize the 8255. We know that the 825, when we go for 8255, we need to initialize the which port we are going to use the input output, which port we are going to use as the output port, like that. Okay, then second step, send SOC to the ADC, that is start of conversion. We need to set the start of conversion through the CL port. So check for the end of conversions, whether all the data are converted into digital, like that. So there is end of conversion from ADC. If no means, read the data from AD. Then store the temperature, digital voltage in memory location. So compare the analog digital to value with the memory locations. So display the equivalent values in degrees. So repeat the step 2 and 7, 2 to 7 for continuous temperature measurement and control. This is the concept. Here we have lookup table. So for analog hex value, they are giving the inputs. If I receive 85 means the digital value will be 9 will send to the processor, then analyze. So this is the flow chart for temperature control. So that is start. That's already seen that step by step. Okay, here start, initialize the 8255, then send SOC, then check a UOC. If no means, it will again send SOC, then yes, read ADC A to D, then start store lookup table concepts, then check with the measured data. If yes means, display the data. If no means, increment the memory location, then again continuously with respect to the comparisons. So this is the assembly language program for executing the temperature controlled concept. So there is a memory location for program is 4000. So that is mnemonics. So first they initialize the value 8255 with the move immediately A comma 98. So 98 is the initial control word register concept. If I put 98 means port A as a port A as input port, port C lower as output, port C higher as input. These are the concept. Okay, this okay, this is the temperature control unit in the power plant. Okay, so only thing for different plant means, so some of the plants are working in the 0 to 20 degree. So we need to use the temperature sensor according to the conditions. Okay, this is the concept. Okay, if you are using a if power plant working in the 400 degrees Celsius means we need to use different temperature sensors. Okay, this is the one concept we need to remember for the analyze the temperature control with the processor. Okay. Okay, thank you. We will see in the next class.